Few minutes. I'm setting. Oh, just few minutes. Incline, I will make it straight. Okay, now okay, I think. Consider a column, material properties, okay. Lambda. Is the board fully visible? Just comment there. Is the board fully okay, clear? I will start now. Good evening. Okay. Just 2 minutes. Voice also fully clear. Even voice also fully clear. If fully clear, we start. If voice also fully clear, no, clear. Okay. See, now, remember, do not see this side. This will come little later. I will come to this little later. Right now, you start here. See, right now, you start here. This I wrote because to save the time. Because this is a previous example. I will tell you why I wrote it. Not for time pass purpose. See, first, some statement I will give. After the class is over, go to recording and write it. First statement. Euler's formula is applicable only for long columns or only for those columns which fails by buckling alone. Buckling alone means what you can tell? The effect of the axial force. See, there is an effect when you apply axial force P, there is a compressive test will come given by P by A. That should be what? Very high or lesser. See, when you apply axial force, whatever axial force you apply, top portion not visible. Visible. Why? Fully visible. Oh, 1 minute. This is other mobile. Just 1 minute. I'll get the. Just 1 minute. Just a minute. Somewhere. I don't know where I kept it. Just time I was having it. I kept it somewhere. I see here. Okay. It's here. Other because there I can't cap. Okay. So I'll repeat once again. See. Now, top portion visible. I think it is visible. Fully not visible. What I wrote, see, here. Oh, maybe this is not visible, I think. I'll come down. See, material properties, cross-sectional properties, these are all visible, correct? Okay, I will come down, no problem. See, 1 minute. I will come down slightly. I will not use up to here. Below this I will write. That lag means okay, now okay. See, write some statements here. You before don't see anything here. Euler's formula is applicable only for long columns which fail by buckling alone, or for that matter, when you derived Euler's formula, any end condition, see, you applied a load PB here, both end pin. It will buckle like this. We considered a section XX here, at X from here, and I wrote this is YX. Bending moment equal to PB into YX we wrote. That is the bending moment due to the load. Actually, when any member is subjected to axial force, here buckling is there. There is one more stress is there called axial stress, sigma axial, equal to force by area. Yes or no? Whether buckling or whatever happens, if you apply a load, see, direct bending, direct compression and bending, if you remember, resultant stress equal to P by A plus or minus M by Z. Yes or no? Resultant stress equal to P by A plus or minus M by Z. Here, tell me, is in the derivation of Euler's formula, the P by A is considered, did we consider anywhere the axial stress or stress, compressive stress due to axial force, P by A? No. Means what? This stress should be, Euler's formula is applicable only if what? This stress should be, some answer came earlier, it is a wrong answer. See, if it is a predominant value, you have to consider it. Tell me answer. Therefore, Euler's formula is derived with ignoring what? A compressive stress due to axial force, P by A. That means what? This effect should be high or lesser. You told earlier, see, high someone told. Now repeat once again. See, you can ignore something if its effect is high or lesser. Somebody answered, some high came answer. Now I am repeating. No, not lesser than buckling. Don't think of buckling. No. That is a wrong concept. If it is lesser than buckling, is a wrong concept. Remember, I will tell you later. It is completely wrong concept. It is not lesser. What you can tell? Instead of lesser, what you can tell? Other word. Lesser means how much less? See, suppose lesser means how much? See, suppose somewhere. Suppose you go somewhere. You up and down bus fare is 500 rupees. Whereas local expense there is 2000 rupees. Tell me, is 500 very small or negligible? Tell me. Is this up and down journey expense, bus fare or train fare, 500? And you are staying someplace, that day you spent 2000 expenses. Tell me, is that 500 is negligible or small compared to this one? Small, no doubt. But is that 500 negligible? No. Is it small? No doubt. Is it negligible? Is it negligible? Tell me. Negligible means you can ignore. Is it negligible? No. In front of 2000 rupees, 500 is not negligible. Suppose somebody has to give you 2500 rupees. He gives 2000. Tell, shall we settle? What you will tell? No, sorry. You have given 500 shortage. Not accepted. Correct? Therefore, this is lesser, no doubt. This is like your P by A. This is buckling effect. So P by A is small, no doubt, but not negligible. Now, suppose you leave Bangalore, go to some place, any place. For example, say any place, say Chennai or Bombay. You spent a train 500 rupees, okay, up and down, and You stayed there for some 10-15 days and you are holidaying there. You spent nearly 2 lakh rupees, your expenses there. Train up and down 500, ordinary class. See, Chennai, okay. Then you went to nearby places all. Now tell me, now in front of 2 lakh rupees, is that 500 only small or negligible? Tell me, in front of 2 lakh rupees, that 500 rupees, is it only small or negligible? It is negligible. You can tell. Suppose someone will ask you, how much you spent? You don't tell him, I spent 2 lakh rupees and also 500 rupees for bus fare. Or suppose you have to give somebody 2 lakh 500 rupees. Suppose you give 500 rupees lesser for some deal, some purchase, one vehicle, second-hand vehicle, one second-hand car. He told 2 lakh and 500 rupees. 500 rupees maybe for registration. Then you tell him, registration please, you only do it. Then you pay the money. No, I don't have money. I have only 2 lakh. Will he agree? Will he agree or not? Will he agree or not? Suppose you tell 500 shortage. Will he agree or not? He will agree. Okay, done, he will tell. So that's important. So remember, one more statement you have to write. One more statement you have to write. See, this is, so many people are ignorant of this fact. See, there's a condition. Euler's formula is applicable. I put dash, dash, dash. This is very, very important statement. I will tell you. So many people will tell, Euler's formula is applicable only if slenderness ratio lambda is either equal or more than pi square E by sigma CR. This we discussed last time? Yes or no? This we discussed last time? Yes. Now, tell me answer. Last time, when you substitute E equal to 210 to the power 3 for steel and sigma CR equal to 330 Newton per mm square, remember, this is unitless. It's a ratio. Tell the number came 70. I forgot. Tell exact number. 70. Some number came. You can calculate now. Don't give wrong number. 70. It came 70. How much? 77 something I told last time. Calculate once again now. Pi square into 210 to the power 3 divided by 330 root. See, concepts are important. All the people who are under the impression that Euler's formula is applicable, if this condition is satisfied, if they go through this class, they will make out how wrong they are. How wrong they are, I will prove now. See, this is only a guideline. I will tell you a little later. This is only a yardstick. If it is less than that value, it becomes nonsense. See, nonsense is different with full sense. I'll give that example. 77.34. Okay. 77.34. Red color required. Red color value 77.34. Okay. Now, do you want to hurry and finish this expression fast without basic concept? Tell me. Without the understanding of the... See, when you go to steel, your column comes always intermediate. It will never come very short. It will never come very long. And slenderness ratio usually comes 80-90 all for steel. If 80-90 comes in the range of 80-90, then Euler's formula is applicable if lambda is more than 77.34. So someone will tell, if you get lambda equal to 100, 100 is very popular lambda in steel structures. Suppose you use ISMB 400 etc. for a length of 3.5 meter, it will come around 100. 100 is more than 77.34. So it is quite long. Therefore, Euler's formula is applicable. But will IS code will give the strength based on Euler's formula then? Tell me. Will see, 100 came, slenderness ratio. Euler's formula is applicable only if the lambda is more than 77.34. Yes, more. So, Euler formula you can apply. Now, will the IS code will give that answer? Tell me. Will IS code will give the result based on Euler's formula? No. IS code will never give result based on Euler's formula. Euler's formula is only a guideline. But remember, if the column is very, 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 very long, like I told you, what? Local expenses 2 lakh rupees, journey expenses 500 rupees, then you can tell 2 lakh rupees. Then correct. Clear? Then correct. Not if your expense is some 2,000-3,000 rupees there, journey is 500 rupees, then you can't tell that way. Or if the journey expense is 500 rupees, local expense is 750. No doubt. Local is more, but 500, 750 are nearby only. Therefore, you never take for granted that whenever lambda is more than pi square E by sigma CR, that is here, for our example, 77.34, oh, Euler's formula is applicable. Okay, then no other formula required. Complete nonsense. I will give an example for you. Complete nonsense. Clear? Okay, now, come back here. See, therefore, Euler's formula does, remember, last conclusion, Euler's formula does not consider effect of what? Axial stress. That is sigma axial equal to P by A. Tell yes or no. It considers only buckling. Axial stress effect is not there. Yes or no? It considers only buckling. Yes. Only buckling means what? If you take usual, only buckling means technically what? Only what? See, due to direct compression, effect is P by A. Due to bending, effect is M by Z. It considers only M by Z. Yes or no? It does not consider P by A. Now clear? It does not consider P by A. It considers only M by Z. Okay. See, in RCC, if the column is long, what IS code told? Tell me. Anybody know it? If in RCC, if the L effective by least lateral dimension exceeds 12, then column is called as what? Tell me. If the RCC, L effective by lateral side S, which side I will tell you in RCC? If it exceeds 12, IS code told the column is what? Short or long? IS code told column is short or long. If the ratio exceeds 12, it is called long. Now, is this L effective by S is slenderness ratio? Tell me. Is that L effective by S is slenderness ratio? Is it slenderness ratio? No. Is that L effective by S is slenderness ratio? Is it slenderness ratio? That L effective by S, is it slenderness ratio? First, is it slenderness ratio? By question. No, it is not slenderness ratio. So many people in the online I have seen, they tell in RCC, L effective by least lateral side, if it exceeds 12, it is called long column. Okay, done. I agree. Then they will tell, so remember, L effective by that ratio, it is called slenderness ratio. They are telling the blunder part. It is not slenderness ratio. If your slenderness ratio, it is what? Not yes. What do you have to take? For slenderness ratio, what do you have to take? You should not take yes. Where you learned yes? It is complete nonsense. Telling that RCC, L effective by S is slenderness ratio is nonsense. It is R minimum. R applicable R if effective lengths are different. R minimum. But actually, R minimum is connected to S directly by what? Remember, 1 by root 12. You know that rectangular section R equal to S by root 12 will come. Remember it? It will come S by root 12. Therefore, that root 12 they considered in 12. Therefore, remember, I will tell all the people who tell L effective by S is equal, either equal or more than 12, they will tell this is slenderness ratio. They will tell this as slenderness ratio is nonsense. Nonsense. But it is connected to slenderness ratio, no doubt. Actually, if it is 12, the real answer is, anybody can tell the answer? A RCC column will be considered long if slenderness ratio is, tell the number if possible. 12 is highest code value. If it is 12, real answer, anybody can tell? Anybody can tell the real answer? Anybody can tell the real answer? They tell long if slenderness ratio, they tell L effective by side is more than 12. So when they tell 12, it is not slenderness ratio. It is your ratio connected with the slenderness ratio, no doubt. Linearly connected. So ratio is correct. Anybody can tell the answer? It is, I will tell you, 41.6. It is 41.6. So in RCC, L effective by side, if it comes 12, it is indirectly means slenderness ratio is 41.6. Now clear? It is 41.6. This I told in RCC, yes or no? This I told in RCC. So calling L effective by S as slenderness ratio is biggest mistake. Technically, a person teaching should never tell that way. He should tell effective length by side. He should tell it is connected. See, if it becomes 24, this will become 80 something. So directly linked. But actually what? Root 12 will come there. So IS code does not want root 12. So what they did? They removed root 12. If it comes to 41.6, then the ratio will come 12. If slenderness ratio is 41.6, then the ratio will come 12. Clear? Okay. This I told in RCC class. At least I told for those who are studying RCC, don't get misguided that L effective by side is slenderness ratio. Nonsense. Okay. But nonsense technically, but calculation point of view, okay. Why? Ratio. Now onwards, I will tell L effective by R. See, strength of materials, we always consider R, that is radius of gyration. L effective by R. R is directly connected to side. That's why it comes correctly. Okay, now, P by A is not considered. They consider only bending. Clear or not? When Euler's formula is derived, they consider only bending. Clear? No axial load effect. No direct compression effect. Axial load effect is there. Why? Axial load only buckles, not that way. That axial stress, direct compression, they don't consider. Okay, now. But actually, 1 minute now, see. This is wrong. Tell why. Axial compression can be ignored only when the column is what? Tell me. Very, very long or intermediate or short. Axial compression can be ignored when the column is what? Very, very. Buckling is when the column is very, very. Axial stress effect can be ignored when the column is very, very. What? When the column is very, very. Some answer. Why this much delay? You can ignore very, very long, then you can ignore. Now, I will give example for you. See now, therefore, make a note. If the column is very, very long for matter, see, long means not only length, this also counts. This is a long or short column, tell me. This is a long or short column, see here. Tell me, this is a long or short column. Don't see length only. This is what column? This is a long column. See, if there is a RCC column there of height 3 meter and cross section 400 by 500, that is short compared to this column. See,
This is long column. If I make a steel column, maybe I 4 channels or etc. I will go for a length of around 3 meter. It is a short. Why? Length is more, but cross section also more. I told you length more or lesser. Column should be thin and deep. Remember, length more and see, length is more and cross section wise thinner. Whereas length lesser or bulged cross section is short. Then intermediate will come, somewhere intermediate. The intermediate is very important. Tell why? Reason. The intermediate is very important because practically when you design, almost all the column come where? They come long, pure long column practically will not come. Nobody will construct a column where it will fail simply by buckling. Nonsense. Very short column you won't get, like sometimes pedestals, small column will come. Usually, practically, all the columns are what? Almost practically, almost all the columns are what? It is not long. It is not very short. Practically, almost all the columns are what? They are intermediate. Therefore, the discussion is more important for intermediate column. Okay, now, the statement you write. Now, come to Rankine. Come to Rankine's formula or Rankine's expression. Rankine's formula. See, what Rankine told is, he know by that time, see, Euler himself told, maybe Euler himself told, don't apply me if the column is what? Very, very short. Intermediate, Euler told intermediate also don't apply. You apply my formula only if the column is like this. That's all. See, not like this. Don't see here. See, not like this. Why? Tell me. See, buckling is there. See, buckling is there. But what is there? Tell me. Not only buckling. What is also there? See here. See here. Where is so easily? Now see. See now. See, buckling is there. But what is there? Buckling is there. But what is there? It's intermediate. Buckling is there. But also what is there? Compression also is there. Then either you cannot apply. This formula will tell you applicable. No. I will give a practical example for you after I finish Rankine's formula. Okay, start. Now Rankine, he proposed a formula. Proposed only. He told, I cannot prove it. There is no proof for Rankine's formula, but it has got logical proof. Remember, Rankine's formula has got logical proof. And he proved it. He told, my formula is applicable for extreme long column and extreme short column. I can survive, I told last time for you, in extreme hot condition, extreme cold condition. When I get full problems, I becomes what? I silently, I will not show any expressions. When I am extremely happy, then also I don't show expression. Oh, that means that person throughout he is same nature. See, if somebody can survive, for example in Karnataka, if he can survive in Gulbarga etc., hot place, and he can survive in Madikeri, very cold place. In Madikeri, you don't know, summer, when my sister's daughter is staying in Madikeri, when I first went there, night time I told him, where is the fan? Not now. Around 30-35 years earlier. Without fan I can't sleep. Then she told me, Mama, fan illa. No fan means I won't get sleep. I told, fan illa nidda baroda. Then she went to neighbor's house and bought a fan. I was told, we don't use fan here. Why? Even now the situation has changed now. 30-35 years earlier, there was no hot there in Madikeri. It is always cool place. So if somebody can happily survive in Gulbarga, Raichur, hot place, or Madikeri like that, he can survive in Bangalore, anywhere. Why? Extreme hot, extreme cold, if he can survive anywhere. See, if somebody can survive in Rajasthan, etc., in the hot climate, and he can survive in Kashmir, like Kargil side, in the extreme cold where temperature goes below 0 degrees, then that person can survive anywhere. Yes or no? Anywhere he can survive. That way. India, see, Rajasthan all, very popular. Sometimes temperature goes above 50 degrees somewhere. Madhya Pradesh, Rajasthan, some places. There also he can survive. If he go to Kargil side, extreme end of India, negative temperature comes. There also he can survive, means he can survive anywhere then. Okay. Therefore, Rankine proposed an expression for failure load. See, he is not using buckling load nor using crushing load. He told failure load. See, tell me, practically, what is more important? To know the strength, what is important? Buckling load important, or crushing load important, or real failure load important? Tell me. For practical design, buckling load important, or crushing load important, or actual failure load important? Design purpose. Which is important? Buckling load or crushing load, or actual failure load? Which is failure load? Why? Of course, Rankine proved if the column is very, very long, he told my failure load will go very near to which load? Rankine proved it. If it is a very, very long column, he told my failure load will go very, very near to what? Tell me. Very, very near to. It will be almost identical. Rankine told if the column is very, very long, he told what failure load formula I am giving will be very nearly equal to. Yeah, which load? Which load? If the column is very, very long, Rankine proved it. It will go and reach which one? Not exactly equal. It will be very near to which load? No. If the column is very, very long, Rankine's failure load, my symbol is PF. Neither PCR, not PB. Tell me answer. Column is very, very long. Rankine proved the load you are getting using my formula will be almost equal to what load? What load? This much difficulty. What load? Tell me. If you don't answer, doubt comes to me. Audible or not audible? Why no answer? It is almost equal to. If the column is very, very long, why this much time you are taking? Once in a while I ask question only to ensure that audio is clear. I do not want talk for more than 1 hour, then finally come to know that audio is not clear. So response required in between. Response required at stages, buckling load, correct. Whereas if the column is very, very short, then Rankine's load will be very, very near to which one? Rankine's load will be very, very near to which load? If the column is very, very short, Rankine's load will be very, very near to which load? If it is very, very short, crushing load. Okay. If the column is intermediate, then it will be in between buckling load and crushing load. Clear? If the column is in between, it will be equal to, it will be within, it will be what? In between buckling load and crushing load. Clear or not? If the column is intermediate, yes. And then remember, if the column is intermediate, buckling load is not the answer. Crushing load also is not the answer. Real answer is Rankine's formula. Clear? Because it will take, if the column is intermediate, it will give the real failure load accounting for both what? Tell me. See, if the column is very long, This all you are right. Rankine's formula will give failure load almost equal to buckling load, considering only buckling. If the column is very, very short, Rankine's formula will give failure load almost equal to crushing load, considering only crushing. If the column is intermediate, Rankine's formula will give via media in between value, which is the real answer because their combination of bending and direct compression both are there. Yes or no? Intermediate, it is a combination of compression with bending. Clear? Compression with bending. No, intermediate column has got effect of compression with bending. Yes, Rankine's formula gives that load. User will give wrong result. Okay, start. PF equal to PF is the formula. This is PF. So PF is the symbol I am using for Rankine's failure load. Sometime in the question paper I have seen, B paper, find the Rankine's buckling load. First of all, they should not ask. One who set the paper, if he comes in front of me, I will tell him, who told you Rankine gave buckling load formula? The person will tell me, no, that column is very long. Therefore, it will be almost buckling load. But that let it come in the calculation. Who are you to decide it will give buckling load? You simply tell question paper, find Rankine's failure load. What to do? People are there. Or Rankine's crushing load. Nonsense. Correct word is Rankine's actual failure load valid for all columns. All columns means either very, very long or very, very short and also intermediate. Intermediate can be anywhere. It can be near here or near here. Anywhere. It is universal. This one clear? If clear, I will go to expression now. If clear, I will go to expression. If this discussion is clear, these are all called technical points you have to remember. Okay, now, see, even tomorrow I got a lecture in a college regarding columns. There, this much all I will not tell them. If I tell them, they can't make out. It is just a column class they want to taken by me. I will tell Rankine's load, little I will tell. This much all if I tell, they will see 1.5 hour time for complete column. How I can 1.5 or 2 hour time? How possible? Including covering the strength of materials, basic ideas and column. Half an hour for strength of materials, 1.5 hour for column. If I tell this way, it will not be students, they can't understand. Okay, now start. According to Rankine, the actual failure load, which is called Rankine's failure load. We call it as Rankine's failure load for any column, any type of column. That is what? Either long or short or intermediate. Clear? Either long or short or intermediate. All this one, that is called PF, is given by PF equal to, he has not called given PF, he told 1 by PF. Now remember, I will go to red color for Rankine. Why? Our blue color for Rankine. He told 1 by PF equal to 1 by PB plus 1 by PCR. Or he told, if you want words, his statement is what? The reciprocal of the actual failure load is, reciprocal of the actual failure load is sum of the reciprocals of Euler's buckling load and crushing load, where PB is Euler's buckling load. Euler's buckling load, and PCR is crushing load. Crushing load. And PCR is crushing load. Remember, I write here Euler's buckling load. Euler's buckling load, you can write pi square EI by L effective square, or you can write pi square EA by lambda square. Both are same. I wrote here once again, see, it is here. I won't tell where, as usual, I is the minimum I, lambda is equal to L effective by R. These all we discussed now. Once again you will come here, see, now not required. And the crushing load, PCR, that is crushing load. Crushing load, here length is not counted. This only for short column equal to crushing stress into area. These all we covered earlier, yes or no? These all we covered earlier. Tell me yes or no. What is the expression for buckling load? And see, these both are same. You replace I by AR square, then you get lambda. Okay, both are covered. Okay, now I will tell you the justification given by whom? Tell me. Justification given by whom? When you propose a formula in structure engineering, unless if it is a derived formula, people will accept it. If it is a derived formula, people will accept it. See, I forgot one thing now. Because of all these days, you may not remember. See, I think I told you earlier, 2 years, 3 years earlier, I told something. I developed my own method for analysis of propped cantilever and fixed beam by a special method which so far nobody considered. My own method. It is a very beautiful method. And someone told me, sir, you present it, you get good recognition. Now because of this, after Corona, suddenly today if I remember it, remember I told, I developed my own method which so far nobody has done it. If it is accepted, it will be named after me only. If it is accepted, it will be like what? Consistent deformation method, moment distribution method, that way. If it is accepted, it should be accepted, it is correct. It will be named after me only. So many people told me, sir, we are eager to know your name that way. But then I completely forgot it now, nowadays. And someone told me, sir, be careful. Such you first to what to do it. There's a word there. It is better to first what to do? Patent. You take patent, register it and take patent. Somebody may misuse it. I told nobody can misuse it because there is not a single writing there. Tell me, everything is where? Complete method is where? You cannot see any writing. Any writing, it is not in written form. Anybody can tell? Where is that method? Complete method, where is it? No written statements are there. Anybody can tell? Where is that method then? Nearly 3 years over now. Today suddenly I remember. It is here. Therefore, nobody can steal from here. So then I told them, no problem. Nobody can steal. Why, sir? Why? Because it is here. Oh, then safe. So therefore, even you also be eager to know that method. It is called correction for slope method. Successive correction for slope method. It not a very fantastic, it is a good method where correct understanding will come. I will think of that little later, not right now. PCR, sigma CR into A. Now, justification given by whom? Tell me. When you propose, see, that is a derived formula. I should take an example and prove it in a committee. They will accept it. But if I propose an empirical formula, I have to justify it. So, therefore, justification given by whom? Justification given by whom? Tell me. Justification for Rankine's expression given by whom? Justification given by whom? I can't justify Rankine's formula. Who justified it? Tell me. Rankine only justified. So, justification given by Rankine. Or he explained, that is validity. he told my formula, that is reciprocal of the actual failure load, is sum of the reciprocals of user's buckling load and crushing load is justified because of the following reason. See, reason. See here. User, what he has done is, it cannot be mathematically justified. Impossible. Why? It is an empirical formula. It cannot be mathematically justified. Therefore, he told, consider a very, 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 very long column. Long column. I will see, you can see tomorrow discussion on that. So many length at see, I have taken different lengths here. These all for tomorrow's class. I first thought, but I will do one thing. I will give exercise for you. You should get ready answer. Tomorrow I will write direct answer. I will explain everything today here, and you make the result ready and send in the group. Okay. Correct answer in kilonewton. Okay. Actually, for 4.2 meter, for 0.4 meter, and something like 16 meter, you know the answer, yes or no? For same problem, for length equal to some 16 meter, 4.2 meter, and some 0.5 meter, you know the answer, yes or no? We did it, yes or no? That answer is there with you. It is in the photograph, it is there. We earlier took the same cross section column. Pipe of outer 150, thickness 10, steel material. Remember, for three, some of them you know the answer. Okay, later, not now. At the end of the class, I will come here and fill up the values, and I will ask you to send the answer to me, type and send. And tomorrow's class, I will not write this much. I will tell slenderness ratio, PF, buckling load, crushing load, Rankine's load. That way I will write tomorrow to understand. Okay, see. You are told this way. Like, consider a very, 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 very hot climate. Exceedingly hot. Some Marubhumi in Canada, desert. Very hot. If you walk, see, you cannot walk barefooted. That temperature is there, and horrible. Temperature is around more than 50 degrees centigrade. Or a column which is very, 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 very long. See, a column very, very long. See here. Oh, what is this? It is not called buckling. Or, see here, this thin paper. Or, this also will do. See here. Tell me. This column will fail only by what? Tell me. Such columns will fail only by very, very, very long column. Such columns will fail only by fast. Such columns will fail only by buckling. Column which fails only by buckling. That is what? Crushing impossible. Or your P by A term is what? Tell me. Your axial force term is like you spend 2 lakh rupees, and up and down journey is 500 rupees. Your camp expenses in the place where you went, you are enjoying a holiday, spending is 2 lakhs, up and down train journey is 500 rupees. Ayyo, what is that? Therefore, in such cases, axial load effect is not there. Clear now? Or you can tell, then the crushing load will be what? Tell me. If the column is very, 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 very long, it will fail easily by buckling. You just see, you just take the column, apply little, see, not even 10 kg. See here. Tell me. Then the crushing load will be very high or lesser. Tell me. The crushing load will be very high or lesser. No. Crushing load is very high or lesser. If the column is very, very, very long, Crushing load is very high or lesser? Lesser. How lesser? Crushing load is very high. You require maybe 10 kg load to buckle. Actually 10 kg also not required. See, 10 kg also not required. See, just maybe 2 kg. 2 kg load to buckle. 2 kg to buckle. Whereas if I take the same steel, make it short, try to crush it, I may require 2 ton load to crush. To crush, I may require 2 ton load. To buckle, I may require only 2 kg load. Clear? That's why crushing will not come. Clear or not? It will fail only by buckling. Crushing will take place at a very high load. Clear? Therefore, what happened? Tell me. Therefore, you are told the buckling load is very less. Crushing load is very high. When crush, why very high? That column cannot crush. Crush means what? If you make that column very short, how much you require for crush the column? It may come in tons. So, crushing load is very high. PCR is very high. Since it is very high, it will not crush. Clear now? Before that it will buckle. See, it is crushing load is very high because before that it will buckle. Then you Rankine told, since the crushing load is very high, reciprocal of crushing load is what? When compared to reciprocal of buckling load, reciprocal of crushing load is what? Tell me. Compared to reciprocal of buckling load, reciprocal of crushing load is what? Reciprocal of crushing load is what? Crushing load is very high. So, reciprocal of crushing load is what? If something is very high, its reciprocal is what? Very less. Or, see here, I can remove this one now. Same example I will tell. See, imagine buckling load is 2 kg, like the scale. Crushing load is 2000 kg. Tell me, this column will fail by buckling or crushing. Long column. When you apply 2 kg, it will buckle. See, actually kg is not allowed, but practically kg is more clear. Yes or no? Newton, people don't understand. So only for discussion, I am telling kg. 2 kg force, it will buckle. If you apply 2000 kg, it will crush. How there is 2000? At 2 kg, it will buckle. No surviving. Tell the real failure load. Tell me. Real failure load, how much? Real failure load, how much now? A column is found to buckle at 2 kg and found to crush at 2000 kg. If you make it short, real failure load, how much? 2 kg. Okay. 2 kg, correct. That is buckling load. Now see, according to Rankine, 1 by failure load equal to 1 by 2 plus 1 by 2000, or 1 by PF equal to 1 by 2 plus 1 by 2000. Okay, now calculate 1 by 2 plus 1 by 2000. How much? Tell me. 1 by how much? 1 by 2 plus 1 by 2000. Answer. 1 by 2 plus 1 by 2000. Answer. 1 by 2 plus 1 by 2000. Answer. Reciprocal format. It will come how much? 1 by 2 plus 1 by 2000. It will make why this much delay? 1 by 2 plus 1 by 2000. Or remember, 1 by 2 is 0.5. 1 by 2000 is, but again, it is 1 by 2 plus 1 by 2000 is what? 1 by number. 1 by, no, I want 1 by, why this much difficulty? See, 1 by 2 plus 1 by 2000 plus 1 by 2000 equal to, take reciprocal. reciprocal equal to 1 by 1.998 or failure load equal to 1.998 or that is, tell what? That is nothing but what? Tell me. That is nothing but what? That is nothing but what? 1.998 is nothing but what? 1.998 is nothing but. That is nothing but. Practically, who will bother? That is nothing but 2 this load. Or, see, why it came little lesser, tell me? Because small compression. See, axial force effect is very small. That's why answer came slightly lesser. Or practically, Rankine told, hey, what is this? Take it as 2, that is buckling load. So he told, see, therefore, in extreme case of long column, my formula will give the same load as the user's buckling load, or if the column is extremely long, but then my column failure load will merge with user's load, or my formula is valid if the column is very, very long. Clear? Tomorrow you will understand correctly all this concept. Tomorrow you will understand most important intermediate value. Remember, intermediate is practical. This class is for practical knowledge. Intermediate is the most important. Okay. Tomorrow you will understand. I will explain everything for you. Don't worry. What all I know, I will explain. But what all I know, everything I cannot explain. Sorry. Clear? Okay. Now, come to another column. See, for example, I will tell you another column. I will show you a column now. Okay. See, a column like this, steel. This area is something. I don't want to tell area now. This is a short or long column. See, extreme this way. Is it a short or long column? Tell me. This one. A steel, not bulb holder, a steel block of 20 by 20 by 20, or even a concrete block of 150 also will do, small concrete cube, or tell very short. This is a short or long column. This is very, 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 very short. Very, 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 very short means its L effective is very small and its R is high. So its lambda is very small or large. Its slenderness ratio is very small or high. Tell me. Its slenderness ratio is what? Slenderness ratio, danger number is, slenderness ratio is very high or low? No, I want slenderness ratio. Lambda, very high or low? Slenderness ratio. You are not answering. Slenderness ratio is very, very high or low? See, L effective is lesser, R is more. First of all, by looking, does it look like a slender column? No, you are not answering it. Slenderness ratio is very high or low? Slenderness ratio. You already answered. Very low. Therefore, this column, see, will fail only by what? Tell me. This column will fail if you apply load. Will fail only by what? This column will fail only by crushing. It will fail only by crushing. For example, imagine 2 ton is the crushing load. Tons crushing load. Okay. Now, tell me, it's buckling load. Any chance of buckling for this column? Tell me. This column, is there any chance of buckling? Tell me. First of all, can you use the word buckling for this column? Can you use? No, it is nonsense. Okay. Or if you substitute PB equal to pi square EI by L effective square or pi square EA by lambda square, your buckling load will come what? Very high or very low? Your buckling load will come very high or very low. If you calculate, The buckling load, see, L effective and lambda are in denominator. Buckling load will come what? If you apply Euler's formula just for fun, buckling load will come very high or low? Very, very high. Maybe this is 2 ton. I will tell you buckling load, say 5,000 tons. It will come much more. Means when the load reaches 2 ton, the column will crush. Then column has to stand up once again and wait till the load becomes 5,000. Is it nonsense or not? When you apply 2 ton load, it crushed. It got pieces. Full dust it became. It will get crushed at 2 tons, and then someone told, I want to buckle. Okay, if you want to buckle, you ask the column to stand up once again. Okay, stand up. Now, I will apply a load of 5,000 tons. You buckle. Nonsense answer. Correct? I told last time, 500 kg voltage, a person gone. 20,000 voltage, 20,000 volt. What is there? That is nonsense. Therefore, this column will fail only by what? Tell me. Very short column. Or sometime you eat like what? Kadlekai in Kannada or anything. When you put in the mouth and crush it, tell me, is it buckling or crushing? That small things you eat. Is it buckling or crushing? Little hard material like groundnut. It's a very small. When you put in the mouth and eat it, are you crushing or buckling? You are going to crush it. You are not buckling it. You are going to what? You are going to crush it. Correct? You are not buckling. You are going to what? Going to crush it. Therefore, now, see here. 1 by PF equal to 1 by PB plus 1 by PCR. Or 1 by PF equal to 1 by PB. Buckling load is what? Buckling load is 5,000 plus 1 by 2. Tell the answer. 1 by 5,000 plus 1 by 2. Answer. 1 by. Bega. 1 by 5,000 plus 1 by 2. Answer. 1 by 5,000 plus 1 by 2. Number. Reciprocal. ABC, I want reciprocal number. 1 by, how much? 1 by 1 point. Answer. 1 by 1 point. Answer first. 1 by 1 point. Number. Don't waste time. 1 by 5,000 plus 1 by 2. 1 by 1 point. It won't be 2. Slightly lesser will come. Number. See, already 840. Don't, because if you delay now, I can't derive the formula. If you delay further, I can't derive the formula today. Fast. See, if you give fast, I can go. Otherwise, I can't derive the formula. Today, I want to derive the formula for expression used for Euler's, Rankine's failure load. See, you are not giving answer. What is this? See, this way not responding is problem. This much lag is not there. You have to calculate and type a number. 1 point. This is, if you do this way, it demotivates the person who taking class. When answer does not come fast, it demotivates. What, are they listening or not? Are they interested or not? Simply I am telling everything. That feeling will come. If you don't involve the no calculator. Okay. 1 point. Answer bantilli 9992. It is 1.9992, or your failure load equal to, see, 1 by PF is 1 by 1.9992, almost equal to what? Tell me. That's again almost equal to 1.9992 is almost equal to how much? Almost equal to. Little change will be there. Almost equal to. When you tell 1.9992, it is almost equal to. This you don't require calculator. For typing this answer, you don't require calculator. 2. Almost equal to 2. So, when the column is very short, your crushing failure load, Rankine gave 2 tons, which is same as what load? Tell me. Which is same as what load? It came 2 tons, which is same as what load? Which is same as what load? Buckling load or crushing load? Again, you don't require calculator for this one. Which is same as buckling load or crushing load? See, this much delay means problem. Crushing load. Or now you prove, Rankine told this way. He told extreme long column. Column will fail by buckling. My load also will tally with buckling load. Extreme short column. Column will fail by crushing. My formula also will give crushing load. Extreme hot, extreme cold, both places I am fully surviving. I am valid. So he told extreme long and extreme short, my formulas, if an empirical formula is found to be valid for either opposite extreme ends, what you can tell? If a formula is found to be valid for extreme opposite sides, what you can tell? People will surely agree. What you can tell? Is it valid for anywhere in between? Extreme cases valid means, extreme opposite cases valid means, can you tell it is valid for any interior cases? Yes or no? Yes or no? Any interior cases? You have tell yes or no. Or if somebody can survive where temperature is 50 degrees centigrade and somebody can survive where temperature is minus 10 degrees centigrade, can he survive when temperature is normal at around 25 degrees centigrade? Tell me. Somebody can survive in Karnataka, Gulbarga no problem, Raichuru Gulbarga no problem, and Madikeri also no problem. Can he survive in Bangalore then? Tell me. Bangalore, Mangalore, Kodar, wherever you want, Davanagere, he can survive. Mysore or what? Mysore, Maddur, anywhere he can survive. Even Satnur, somebody from Satnur is there. Even Satnur also he can survive. So this is justification given by Rankine. And tomorrow, remember, we will understand correctly intermediate case what happens, extreme case what happens. Tomorrow you will understand using the numerical example. Clear? Tomorrow you will get full control on column behavior. Clear? Tomorrow you will get full control on column behavior. If you correctly understand and go through the class and study everything I told, tomorrow you will get full control. Okay, now start. Now I think time is not there. I will go for derivation of expression. Actually not derivation. Expression for Rankine's failure load. Rankine's failure load, which is expression means most commonly used. Okay, start. First of all, Rankine proposed, or according to Rankine, actual failure load valid for any column, any type of column that is long, short or intermediate, that is called PF. That is PF is given by reciprocal of PF equal to reciprocal of PB and reciprocal of crushing load. This is Rankine told. This is the original formula. Remember, this is the original formula. Now you are going to simplify this one, get an easy formula. Or now start. Therefore, 1 by PF equal to, see here, take common denominator, PB PCR times PB plus PCR. Common denominator take here. For PB PCR common into PB plus PCR. Fully clear? Tell me. Fully clear or not? Fast tell me. You are keep on telling clear or not now. So 1 by PF equal to PB plus PCR divided by PB PCR. Fast tell me clear. Okay. Or PF equal to, take reciprocal, PC PCR divided by PB plus PCR. Tell reciprocal. This also clear? Fast. This is the original or what Rankine told. Now we are simplifying. Clear? Okay. Now substitute PF equal to, right, substitute PC equal to crushing load PB, buckling load PB, Euler's buckling load PB equal to pi square E into either EI by L effective square or pi square EA by lambda square. We always want lambda. So pi square EA by lambda square, and crushing load PCR equal to crushing stress into area. What you get? You get PF equal to, see, PB. Or no, 1 minute now. Before that, something else is there. Before that, or PF equal to divide both numerator and denominator by PCR, PB. You divide both numerator and denominator by PB. That is the popular version. Why means just for fun. You divide a ratio, both numerator and denominator by same value, answer will not change. Yes or no? If you divide by PB here and divide by PB here, value will not change. That is common sense. What happens now? Divide by PB. It becomes PCR divided by PB is 1 plus PCR by PB. This is also clear. Divide both numerator and denominator by PB. Then equal to, now substitute PCR equal to sigma CR into A divided by 1 plus PCR sigma CR into A divided by PB pi square EA by lambda square. This AA will get cancelled, or you will get now, see, I write here now. This space I don't want to waste. Now you will get PF equal to sigma CR into A, that is actually crushing load, divided by 1 plus AA cancels. You can see here sigma CR by pi square E. Sigma CR by pi square E is a value into, see, 1 by lambda square is lambda square. Now sigma CR is crushing stress for the material. I wrote already. And E is modulus of elasticity for material. So sigma CR and E are material properties. Material properties. They are material properties. Yes or no? Crushing stress and what? Young's modulus, they are material properties. Tell yes or no. You type yes or no. No clear. Yes. Therefore, sigma CR by pi square E, it is purely material constant. Constant for a material. It is constant for a material. And it is called Rankine's material constant. Rankine's material constant. Material constant. And universally accepted symbol, that is called alpha. Some people call A, no. Universally 99% people, they call alpha. Or you can tell lastly answer, therefore the expression for Rankine's failure load, that is PF equal to what is it? Sigma CR into A divided by 1 plus alpha into lambda square. I will thoroughly explain what is the meaning of this denominator. Anybody, I will tell you tomorrow what is the meaning of denominator, or 1 by 1 plus alpha into lambda square. Anybody can give a name now if possible. See, 1 by 1 plus alpha lambda square. Anybody can give a name. I'll be very happy. This came lot of times in RCC and steel. In steel came so many times. Or you can tell, see, it is sigma CR into A, that is crushing load, into, tomorrow I will tell, 1 by 1 plus alpha lambda square. So anybody can tell 1 by 1 plus alpha lambda square is actually called, anybody can tell? Let me see. Anybody can tell? I will tell you tomorrow, not today. Anybody can tell a good name for this one? Anybody can tell a good name for this term? 1 by 1 plus alpha lambda square. If yes, tell me, or tell don't know. Either you give a name or tell don't know. Tomorrow I will tell. You think one day. Beautiful name is there for that one. If you don't know, tell don't know. Don't waste time. If you don't know, tell don't know. Tomorrow I am going to tell. Not today. Some will tell, oh, maybe today is not knowing. Yes, I am not knowing. I am not knowing. I will study and come. Don't know. Okay. So tomorrow, sometime people will tell, maybe North India is proper. Sir को पता नहीं, इसलिए पढ़ के बताएगा. हाँ, पढ़ के बताएगा. ठीक है. पढ़ के बताएगा. This much I told. This I want to study and tell. Okay. So this is the formula for Rankine's failure law. Clear? Final expression. Tomorrow in the board you can see big letters. What? Original proposed Rankine formula is 1 by PF equal to 1 by PCR plus 1 by PB. And if you simplify that one, finally your PF comes sigma CR into A by 1 plus alpha into lambda square. Alpha is called Rankine material constant, given by that alpha equal to what? It is sigma CR by pi square E. Or I told yesterday how to remember. If you take reciprocal of this one, take root, you get that conditional number here. Correct? Or the conditional number here, lambda, if you square it and take reciprocal, you get alpha. Did I mention that one? That all I'll explain tomorrow. Did I mention earlier or not? Did not I mention it earlier? I told earlier, see this we got. If I remove the root and take reciprocal, you get alpha tomorrow. Or today what you got alpha, if you take root but with reciprocal, you will get back the old number of Euler's validity number. Correct? Okay. Now, that's all. Further 4 minutes I can't do anything. Discussion on this number. Shall I tell the meaning of this number today or tomorrow? Somebody may think, maybe he is not knowing. If you think I am not knowing, I will tell and go. Or you want to think. Actually, better to think. Tell me. Thinking means your concept becomes sharper. Tomorrow when I tell you will tell, Kannadalli, Ayyo, idu gottu sir nanage. Hindi, sir mujhko pata hai. In English, I know it. Then tell it. Sir, that time I did not understand. Now I got it. Once you told, understood, sir. Like I told you, lambda should be either equal or more means that number is minimum for applicability. Same way, there's a name for this one. In steel, it is there. In steel structures, IS 800, this is there in the same format. See there. Bring IS code. Same format, but some empirical additions are there. Same format, it is there in steel also. Okay, better think. Okay, tomorrow I will continue for this one. Sorry, this all I will prepare the answer, no problem. I thought I will give different length and get the answer. Time is not there. Tomorrow what I will do is, I will write the length here, get the answer ready. Why? This is already over for you. So result you can check later. Tomorrow I will go to discussion of the Rankine's formula and explain the importance for intermediate column. Then I will take up numericals. Okay, thank you. Today's class, remember, full of explanation part. Go through everything. Everything go through. Don't waste time. Everything I tell, maybe sometimes I repeat. That is my habit, what to do. I tell same thing 3-4 times. That I cannot do anything because I feel if you tell something repeatedly, then it goes deep inside the mind. That's the only reason. And for information, FPM class at 9:15 is there. Maybe 2-3 minutes this side, that side. FPM class is there, 9:15. Maybe that 3-4 minutes this side, that side. This side is not there. Why? When this much I shouted, 9:15, I may take 9:20, that's all. I may take 9:20, that's all.